Welcome back from the break. I hope you are revived, refreshed, and that you're ready for more. We are going to go on with acids and bases. We looked at titrations in the previous session. I would like us to look at the hydrolysis of salts in the session to come. Right, when we look at hydrolysis of a salt, we will use the terminology hydrolysis, and during my explanation, you will understand what hydrolysis means. So, hydrolysis is the reaction of a salt with water that may cause the change in pH of the solution. What you should remember is a salt is formed by having an acid reacted with a base in a neutralization reaction. It forms a salt, and if we take that salt and we now react that salt with water, if that salt and water have an alteration in the pH, or if the pH is changed, then we say that changing of the pH of the salt is actually hydrolysis of the salt. When we look at ammonium chloride, now ammonium chloride is a salt, and firstly you must be able to tell us from which acid and which base does ammonium chloride come from. Now if I write ammonium chloride, you can see clearly that it must come, the anion part of it is coming from the acid, and the cation part of my salt comes from the base. So you can clearly see that we had hydrochloric acid that reacted with ammonium in this acid-base reaction. So the hydrochloric acid transferred a proton to the base, and what will form here is the ammonium ion, or in this case ammonium chloride, and we also know water was formed. So if you look at ammonium, and the ammonium ion, you can see the difference between the two is an H+ difference. So obviously ammonium is a weak base that will form a strong conjugate acid. The solution then, because of the strong acid and the weak base, the solution will then be weak acidic. Right, so ammonium chloride dissolves in the water. Here we see the reaction. It forms hydronium ions and ammonia, and we know that the ammonium ion is a strong acid because it was coming from a weak base. So your strong acid donates this proton to water. The proton is donated to the water. The water then becomes hydronium ions, and the ammonium ion is now ammonia. So more of your hydronium ions are formed, and we know that where we have more hydronium ions in solution, we know that it is acidic. So when we have more hydronium ions, it means that the pH will be less than 7. When we look at sodium carbonate, firstly, I always say if that is the child, who's the mom and the dad here? Now again, I said a little earlier that the anion or the negative ion of my salt comes from the acid, and the positive ion or the cation comes from the base. So we can see that the base here must have sodium in, and the acid here must have carbonate in. So we can see that the acid that was used was carbonic acid, and the base that was used was sodium hydroxide. Now we know from strong acids and strong bases, weak acids, weak bases, we know that sodium hydroxide is a strong base, and we know that carbonic acid is a weak acid. So if we look at the carbonate ions here, carbonate ions is the conjugate base of the weak acid, meaning that the carbonate ions is actually a strong conjugate base because it comes from a weak acid. So being an acid in the reverse reaction, it will actually now accept a hydrogen ion, and when it accepts the hydrogen ion, it forms water, and the solution then is weak basic. How do we know it's weak basic? We have a strong base and a weak acid. So I normally think in terms of, if this is my neutral point, if I have a strong base, the strong base will be from that side and your weak acid will be more or less like that. So if this two starts to neutralize each other, it will form each other at a point that will be more or less weakly basic. When sodium carbonate dissolves in water, here's the carbonate ion. The carbonate ion will then receive a hydrogen ion, or we can say the water donates the proton, and we have hydrogen carbonate ion, and we have hydroxide ion that is formed there. So now we can see there's more hydroxide ions in solution, and we know more hydroxide ions in solution means that we have to do something to do with the base. So in this case, we have a base, and a base means that the pH is slightly more than 7. Why do I say it's slightly more than 7? Because the base is a weak base that will form. When we look at sodium sulfate, with sodium sulfate, when that dissolves in water, the first thing that we will look at is if this child is sodium sulfate, who's the mom and the dad, then I would say the sulfate comes from the acid and the cation comes from the base. So here we can see that a base with a sodium in is a sodium hydroxide, and we know that it's a strong base. So we have the strong base sodium hydroxide, and an acid with a sulfate in is sulfuric acid. And we also know that sulfuric acid is a strong acid. So what we have in this case is we have a strong acid and a strong base that actually reacted with each other. So the salt was formed by a strong acid. The salt was formed by the strong base that reacted with the strong acid. So in both cases, we know that with a strong acid, sulfuric acid, and a strong base, sodium hydroxide, both of them will always the acid will completely ionize, and the base will completely dissociate, meaning that they are more comfortable in ionic form. The equilibrium will always lie far to the right, more products than reactants. So in both cases, having a strong acid and a strong base, both of these molecules will always try to dissolve as much as possible to form the sodium ions and sulfate ions, as well as the the sodium ions and the sulfate ions of your salt. Both of them will not dissolve in water. And if they don't dissolve in water, we say they do not hydrolyze, which means if they do not hydrolyze, they are coming from a salt that's neutral. And a neutral salt has got a pH of 7. Right. A salt formed by a reaction between an acid and a base, we know for a neutral salt with a pH of 7, the ions will not react with water, and we then say it will not hydrolyze, meaning it will not react with water, and the pH will therefore not be altered. So that only happens when we have a strong acid reacting with a strong base. that we have a salt that will have a pH of more or less 7. And that indication of that pH of more or less 7, if we would try to find out the pH, we will also see that we can then see from our two reactants, strong acid, strong base. Ions of a strong acid will form weak conjugate base, and it will not accept hydrogen ions, and it will therefore not hydrolyze. If I can think of the ions of hydrochloric acid will be hydrogen ion and chloride ions, they will much rather want to be in this format, so they are weak conjugate bases and they will not accept this chloride ion will not accept the proton in the reverse reaction. Ions of a strong base, that is now sodium and hydroxide ions, will form weak conjugate acid and it will not donate a proton. So it will not hydrolyze. It will stay in ionic form and the pH will therefore not be altered. A salt formed by a reaction between an acid and a base. For a weak acidic salt, meaning a salt that's got a pH of just smaller than 7, the ions from the acid will not hydrolyze because the ions will most probably be from sodium chloride, sulfuric acid, but the ions of the base will hydrolyze, and that will alter our pH. If we look at a salt formed by a reaction that now forms a weak basic salt, meaning something with a pH of bigger than 7, the ions from the base will not hydrolyze, meaning we will have OH minus in solution. But the ions from the acid will hydrolyze, meaning that will alter our pH. And for that reason, a strong base and a weak acid will form a weak basic salt. And that brings us to that time again where we will take a break and come back refreshed. Enjoy your break.